Welcome back everyone, this is Shadow Drake, and today I have yet another build video for you. This build video will be all about the printer recipe queue system that I have kind of created to work predominantly with the stack commands. So all in all, it is basically what you see on the board here, and it's the other side to it is basically a display above the printers to let you know what is missing. Now I have it set up for only the four printers, the autolathe, electronics printer, pipe bender, and rocket manufacturer, just because I feel like those are the most common printers that you will be using to queue up items. You could potentially add others to it and can kind of work with the system. It should be able to work with them. It just requires a little bit more thought to add the extra tidbits. So let's get to the nitty-gritties of exactly what to expect from here. As far as required materials, you need several consoles. I would say about 3 consoles for the recipe system itself, 2 consoles per printer that you intend to use, and you will need 2 hash displays for the recipe system, and another hash display per printer. You will need 7 total logic switches and buttons, as you can kind of see. It's very button heavy, but it's, for a system like this, I kind of prefer a little bit more customizability for that. And you're going to need 1 memory chip for this system for the buttons and 1 memory chip per printer. So, and the final thing will be an LED diode slide per printer. So just to sum up, you're going to need 2 IC housings. The main queue will need 7 logic switches, 3 consoles, 2 hash displays. Each printer themselves will need 1 memory chip, 2 consoles, and a diode slide. Oh, plus a hash display. So that kind of covers up the general materials. So now let me go with a quick demonstration of this system. So for this system, you will have the ability to select which printer you're going to print a job from. So for example, the electronics printer. You will have a dial that selects what recipe you want to do on said printer. And I have it straightened out so that you don't have matching things. So you only get recipes on the printer that it affects, or that can actually print this stuff. Now put generally the most common things you will be printing. You have a quantity dial that can go from 0 to 250 to set exactly how much of an item you want to print. And then you have a button to queue it, and what this does is it adds that specific code. Like for example, after I press that button, I added the cable code of 2 to my electronics printer queue, and if I wanted to add another item, I could do heavy cable 2, push the button, and it also adds that to the queue. I have an eject control, and basically it determines whether you're going to eject none of the ingots and alloys, super alloys only, all alloys, that's super alloys and normal alloys, and then 3 is for every single ingot and alloy. Console to show how much is queued, and then finally a send button to send the job to the respective printer. And in this case, on the other end, what the display will show will let you know if you're missing any ingredients. So for example, I'm missing copper to print the 2 cable coils. So if I just throw my copper in there, it's going to print the 2 cables that I told it to. Now it's doing the heavy cables, but I'm missing gold. So now if I fill it with gold, it's going to print that. And you see the little progress bar for the diode slide so that you can kind of see what's going on. And since I told it to eject everything after the print is done, there you go. The whole print is done. I got my cables. So I made this to be fairly customizable, something that you can build early on to kind of automate print jobs, because let's just be honest, sometimes you just want to go mining for stuff and you want to have something printing in the background while you're doing some mining. And that's kind of why I created this system, because let's just be honest, you could print cables until you run out of copper, or you can print exactly how many cables you expect to use up. Same thing for all other stuff. One other feature of the system is if you start queuing a job for a printer, you cannot change the printer. As you see, it is set on the electronics printer until either you send the job or push the reset button. And the reset button clears the queue, but it also clears an active job on the printer. So for example, if I made the mistake and told the electronics printer to print, I don't know, 62 heavy cables, 62 heavy cables, I sent it. Clearly, it doesn't have what it needs, and you're like, oh, well, now I lock my printer. I don't want to print this job. You can come back here and, while still selected to the electronics printer, press the reset button, and that removes the queue and gives you back control of the printer. Now, one of the things about this is that it will automatically turn the printer on and close the lever if it was open for whatever reason. So I send it, you see it close the lever, and it queued the job. So that's basically my system in a nutshell. It's meant to be fairly simplistic, something you can build early on. It's pretty much just tied to IC housings, consoles, LEDs, cables, and signs if you wish to use the signs. So, the script, let's see, there in the video description I have links to the chips. So, and I did not build a computer here, so let me just go over how to set it up. The first things I'm going to say, I have a housing for the recipe handler, and I have a housing for any missing IDs. Their pin IDs are exactly the same. D0 is the auto lathe, D1 is the electronics printer, D2 is the pipe bender, D3 is the rocket manufacturing. D4 and 5 are spares. You could potentially add other printers like the tool printer, security printer, or the automatic oven if you so desire. I left that option as open because, to be honest, I didn't really want to add that extra stuff just yet because they're not common enough, or I don't feel they're common enough that I need them in this chip, but I can add those if needed. So let's talk about the missing ingredients housing. So first of all, once again, ingredients need memory chip, console with the hash display, small LED console, and a diode slide. Now, the hash display console will be tied to the memory chip for that printer. And as you see, they all have a name like lathe miss 1, lathe quantity, lathe composition, or lathe completion. And the console, you could name it, but it's not necessary for the script. The script only requires the memory, the small console, and the diode slide to be named for it to work properly. So let's get on with the script. So when you are going to pull the data from the Steam Workshop, once again, subscribe to it, and it should show up in your library tag. The one for the missing recipe reagent is called the iterative printer reagent lookup. Look, I named it. I'm sorry. I need better names. But as you can see, when you load it up, it will tell you what the pinouts are supposed to be. I do have an alias for the lathe that's not being used. We have all this stuff. Key things to note. Lines 21 to 32 will be the hash names that for the memory, the console, and the diode slide. So take care that these names need to be exactly what you put out there. And if you're going to change the name to something else that makes more sense to you, these will be the lines to change it. You do not need to touch anything else except for possibly one other thing. Line 12 for the max index, you will need to change this to whatever the number of machines you will control minus 1. Right now I have it set for 4 different machines, so I wrote a 3 in here. If you're going to not have the rocket manufacturing, because chances are you're not going to build that early on, and you're just going to have the lathe, the electronics printer, and the pipe bender, change this number to a 2. Because remember, that's 3 minus 1 is 2, and that will suffice. You'll still have the data for the rocket manufacturing, but you will not. If you're not going to need that, then you won't need that. Everything else should run fine as soon as you name those appropriately. Export it to the chip. slot it in, you're done. That takes care of the missing reagents. Key thing to note, this will only ever work so long as you're actually sending stack commands to the printer, either through my system or some other system. The only thing that will work outside of that will be the diode completion, because you can queue up a job and that will still fill up to show you. Now, the next one will be the main chip for basically this whole setup over here, and it's got quite a lot more hash naming for you to take care of. So, but before I get to that, let's take care of the dials. So for the printer select dial, I have it set to 3 because, again, it's just like the housing for missing reagents. It's the total number of machines minus 1, because 0 is a valid number for a machine, for the dial, and because you can't make that go from 1 to 4, I decided to go 0 to 3, and so I'm using 0. So that's why you do that. Now for the recipe style, I got that up to 49. I have allotted 49 stack pointers worth of data per printer. So 49 is the max there. You could have it smaller, or, well, you can have it smaller if you desire. I believe I only have about 30 recipes max, and that's the pipe bender. The quantity dial, I got it up to 250. I don't know that you'll ever want to print 250 items, but I got it up to that high. Honestly, I feel like 50 or 100 is a good safe number to stop at. For the eject control dial, 3, because 0 to 3 is all the numbers you need. So that takes care of the dial settings. So now let's go. Well, I have 2 scripts in the workshop for this. One script will be the Stack Initialization script, and it's something that you do to set your recipes. And it is something highly customizable to you, but I just got a bunch of common recipes. I may have left some out, and I'll show you how to add them while I'm doing that portion. So let's get the IC housing for the controls, and first you will need the Stack Initialization. So let me clear that. Go to Library, and that will be called Printer Recipe Stacks. Load it to your laptop, and as you can see, it really is just a bunch of push instructions. The way I have it separated is stack pointer 1 through 49 will be autolathe recipes. Stack pointers 51 through 99 will be electronic printers recipes. Stack pointers 101 to 149 will be pipe bender recipes. Stack pointers 151 through 199 will be rocket manufacturer recipes. Now, if you wanted to add another printer or so, I have reserved stack pointers 201 to 249 for another printer, and 251 to 299 for the final printer. How I cycle through the printers is through indirect addressing, and so for that I had to use all 6 pins, and unfortunately 6 pins worth of printers is all that I can fit. So I have that space reserved, and you can choose to use it if you want to, but this is how you add extra recipes to the printers. To go over that, I listed the push and the hash ID for the items. So when you load the script, use it as a general, I would say a good starting point for a bunch of common items and kits. But if you find, for example, that you don't want a specific prefab hash ID, like for example for the electronic printers, I have one for small battery. If you don't want small batteries in there, you can either comment it out or just outright delete that line. And that's the same for all the printers. Such as like the autolathe, iron frames. If you did not want iron frames in this, you can do the same thing. If you find that there is an item here within this recipes that I did not include, you can go ahead and add them. So for example, I did not add any of the basic solar panels. So if you wanted to add the basic solar panel, just start a push instruction. Go to solar panel, for example. Solar panel basic. Now, keep in mind you have to get the kit. Copy the prefab hash ID, paste it. Done. That's how you add hash IDs to the script. Now keep in mind that I use just about the entire line space, so if you need to, you can go ahead and delete some of these lines or comment them out so that it does not overwrite that. I'm going to go ahead and delete that because it's not needed. So once you finish messing with adding hash IDs or verifying it and removing stuff you don't want, then you go ahead and hit confirm, export it to the chip, slot it into your housing, make sure it's turned on, and then you see that yellow blinking light. That lets you know that the housing has all the stack data loaded. If you just want to confirm again, you remove the chip, slot it back, watch the housing blink. Once you've done that, you can rest assured that all the recipes are stored in the chip and is ready to go. So now for the final part, let's load the actual brains to the whole chip. And that will be called the recipe printer recipe controls. There's this. So that's the Steam Workshop. Go ahead and load it. There we go. Now, as far as things go, you don't really need to do much in the way here. You do have lines 14 to 22 will have the names for the relevant devices, like your 4 dials, your 3 buttons, your console, and the memory. So if you ever need to change the names to something that's more suitable to you, lines 14 to 22 are what you need to change. But otherwise, as soon as you load this and you confirm that the names are correct, you can confirm, export, add it to your housing. And the system is good to go. Now, I don't think I covered that. I think completely forgot the hash display for the machine show console. You tie that to the housing for the recipe control chip, because the housing will have the recipe for the kit of the machine. That way it'll change that visually. The console that shows the recipe needs to be tied to the memory chip called memrecipe. I believe that is the bulk of this, so feel free to build this, set this up for yourselves, and like I said, use it to your advantage to set up multiple print jobs so that you can be rest assured that when you go to do mining or any other thing around the base, you can set your printers to do all sorts of jobs for you, and you can be rest assured that you're not going to spend your 500 copper printing strictly cables. You'll print only exactly what you need and be satisfied with the results. Let's see, did I cover? Not sure if I covered this, but yes, I did cover it. That if you queue something on one printer, you can't change that. I believe I covered that. Yes, I did cover it. My brain's gone on to me. One thing to note, you can send recipes to every single printer. If, for example, I could queue iron frames to the auto lathe, and you can see that the auto lathe is printing that. I don't want it to spend my iron, so let's just send it steel frames instead. See, now it's going to show steel frames. I forgot to mention, it does lock the printer, so you are unable to do anything to the printer unless you reset it or wait for its job to complete. But by that logic, you can queue jobs for every single printer, and every single printer will work on its respective jobs. Alrighty guys, that shows my build demonstration. So hopefully this is something that can be of help to you, whether it's on a server where lag can make it really hard to queue exact quantities, or just this is just a system you can build fairly early on. Doesn't really require any high-tech materials, just literally printers, IC housings, logic switch consoles, and IC programming utilities. So, thank you for your time. I hope this will be something that can help out, and later on I will see if I can tie something like this to a cargo Larry. Alrighty, have a good day and good night.